Hello, Knights. Welcome to your next lesson in algebra. Today we are talking about something called the distributive property. It's actually going to be a 2-day lesson because it's a really big deal and it's a pretty challenging concept, but once we finally get the hang of it, it starts to get a little bit easier. So, we're going to start out by doing an engage and something that you maybe have done before, but if we do not remember, notice here it says using any method you know, find the total area of the family room in the office. So some of us may be like, oh man, I don't remember how to do the area. So to find the area of something, area equals the length of something times the width. So the length times the width. So in this case, we have two rooms here. We have a family room and we have an office. You have the lengths and the widths of them, and I want you to go ahead and pause the video and calculate in this space down here, right here, where it says here, calculate what you think the area is. Then we're going to review two different ways that we could have done this, and hopefully one of them is the same one that you used. Okay, so go ahead and pause the video now, find the area, and whenever you're ready to check your answer, go ahead and resume. Alright, so like I said, area equals length times width. So there's two different ways that we could have done this. I'm going to start with the one that I think most of us probably did, but if this isn't the one that you did, that's okay. So we see here the family room is 11 feet on one side and 13 feet on the other. So what you probably did was you took 11 and 13 and multiplied. And that's actually kind of what we see here in the method 1 box. 11 times 13 here. And if you calculated that, 11 times 13 should have given you 143. Then you may have seen that there was the office here. The office was 11 and 7. So the area of that would have been 11 times 7, which is 77. And the total area there, if we had 143 plus 77, 7 plus 3 is 10, 7 plus 4 is 11, plus 1 is 12, so we would have gotten a total area of 220. And my expression for this that I'm going to write, I would do 11 times 13 for one room, and then I add that to the area of my second room, which is 11 times 7. Now then, some of you may have done something a little bit different. Some of you may have been like, you know what? I can see that this entire room actually makes one big rectangle. So this is 11 feet here, but up here, this is 13 and 7 feet. And if I put those two together, 13 plus 7 actually gives me 20. So you may have noticed that this is an 11 by 20 rectangle. So you might have added the 13 and the 7 to get 20, and then 11 times 20, what do you know, also gives you 220. And this expression would be 11 times, oh, come on, 11 times, parentheses, 13 plus 7, because in this method you added the 13 and the 7 first, and then you multiplied. In the first method, we multiplied the 13 and 11, and then the 7 and the 11. So the expressions look a little bit different. So there were two different ways to do this. There are several problems here that I want you to go ahead and try on your own without me. So you're going to find the areas of the arrays using either of the methods. So you can either add them up first and then multiply, or you can multiply them separately and add. It doesn't matter. Here, make sure you're writing your expression, meaning like up here where I wrote either this thing or this thing, whichever way you're solving it, make sure you're writing your expression, and then there's a space for your area. Whenever you're ready to check these four, go ahead and unpause the video and we'll go over them. Alright, so we're going to go ahead and start checking these. I'm going to do method 1 first, where I find them by pieces, and then method 2 second, where we add them together. So if we did method 1, then for this first box, we would have had 4 times 6, which is 24. Then we would have had 4 times 9, which is 36. So my expression would be 4 times 6 plus 4 times 9. And if I add these two together, 36 plus 24 would have given me 60. Some of you may have been like, I'm going to add and make one big rectangle, which is perfectly fine. And that would have been 4 times 6 plus 9, which makes 15. And 4 times 15 also would give us 60. So the area here would have been 60. On the next one, if I had broken it into 2 pieces, 12 times 6, oh my goodness, that is so sloppy. 12 times 6 equals 72. And here, 6 times 10 equals 60. So my expression would have been 6 times 12 plus 6 times 10. 6 times 10. And again, if you had decided to draw both of them together, it would have been 6 times 12 plus 10. Either way, 72 plus 60 gives us 132. So the area for this one should have been 132. For the next one, 5 times 9 gives me 45. 8 times 5 gives me 40. My expression would be 5 times 9 plus 5 times 8. Or if you did it with the big square, it would have been 5 times 9 plus 8. Either way, 45 plus 40 makes 85. So the area was 85. All right, and the last one, 15 times 4 was 60. 4 times 5 was 20. Oh, come on. The big rectangle would have been, whoops, let me write my expression first. 4 times 15 plus 4 times 5. And my big expression would have been 4 times 15 plus 5. And then 60 plus 20 is 80. So my area would have been 80. All right, so we've got some good practice on this side. Now we're going to go to our key point. Just like last time, before the key point, I've got some jokes for you. So, my first joke. How do you get rid of a 1? You put a G at the beginning. That one's a thinker. All right, key point number 1. We can distribute values across parentheses without changing the value. So you may be reading that being like, what are you even talking about? So the word distribute, if you don't know, distribute is like where you hand something out. Like whenever I'm passing out your tests and you're all being miserable, I'm distributing the tests to you, right? Whenever you're going through the lunch line and you're getting your lunch, the cafeteria workers are distributing the lunch to you. They're handing it out to everybody. So the distributive property of multiplication states, all right, this one's going to sound confusing. A times parentheses B plus C equals A times B in parentheses plus A times C in parentheses. All of that doesn't really make sense when you say it out loud, but there's a handy little trick that we do to show what exactly that means. So I'm going to distribute the A to the B, and then I'm going to distribute the A to the C. And then notice here, it's A and the B together, A and the C together. We've actually just been proving this over and over and over again. We already see examples of how that happens. We proved it here where we said 5 times 4 is 60. 5 times 4, 15 times 4 is 60. 4 times 5 is 20. When we put them together, it gives us 80, which is the same thing as if we had just done here 4 times 20. So we've already proved it over and over again. It's just saying we're allowed to pass the a along through the parentheses, and it doesn't change the value. It keeps it the same. So, for example, here, 3 times 5. If I wanted to rewrite this using the distributive property, this is 3 times, parentheses, 5 plus 7. And it's going to be the same if I distribute the 3. It's the same thing as 3 times 5 plus 3 times 7. They give you the same value. In the second example, we have 4 times 8 plus 10. If I distribute the 4 to the 8 and to the 10, it becomes 4 times 8 plus 4 times 10. And they're equal to each other. So there are a couple of CFUs here where you're just going to rewrite the expression. Okay? When I see rewrite, that means do not find the answer. Just rewrite the problem and draw an array if you need to. Since I don't want you to be super confused on what this should look like while you go through all 4, I will just give a quick sketch of the first one. So you have 8 times 9 plus 3. Come on, my arrows. You're going to distribute the 8 to the 9 and to the 3. So this equals 8 times 9 plus 8 times 3. And the array, if I want to draw it, would look something like this. Here's 8, here's 9, here's 3. 8 times 9, 8 times 3. This piece here, and this piece here, plus this piece here, and this piece here, are equal to each other. Okay, so now go ahead and pause the video. Whenever you're done with the next 3, resume it, and we'll be ready to check our answers. All right, let's do this. Our next one, if I draw an array, I have 5 and 4 and 12. If I split it here, this is 5 times 4, 5 times 12. So this is the same thing as 5 times 4 plus 5 times 12. All I had to do was distribute. I didn't solve for the answer. All I did was pass the 5 out to the 4 and the 12. The next one, going to pass the 3 to the 1, then the 3 to the 4. Draw my array. Here's 3. Here's 1 and 4. 3 times 1, 3 times 4. So 3 times 1 plus 3 times 4. And again, if I wanted to match the pieces, here's 3 times 1, 3 times 1. Here's 3 times 4, 3 times 4. And for the last one, I'm going to distribute the 8 to the 3 and the 8 to the other 8. So this becomes 8 times 3 plus 8 times 8. And to make it match, here's 3 and 8. 8 times 3, 8 times 8. All right, so why are we spending time doing this? Some of us may be seeing this and being like, okay, I get it. Like, whenever I multiply the two pieces and add them together, it's the same thing. Well, the reason that we're doing this is because now we're going to add some kind of like algebraic twist to it. So the next section says, what if we are using variables instead of a known length? What if I've got some kind of a rectangle and I don't know what one side of it is, right? Here I have x. I don't know what x is. It's some number, but they don't tell me. But I know that the other one is 4 and 8. Well, I can still kind of solve this the same way. To find the area, I know whatever x is, I'm still going to multiply it by 4. So it doesn't matter what x is, this is still going to be 4 times x. And I know that no matter what x is, this is still going to be 8 times x. So my expression here, this is x times 4 plus 8. And I know it's going to be equal to 4 times x plus 8 times x. Oh, come on, that is so sloppy. There we go. 4 times x plus 8 times x. So now it's saying, what would be the area of the two arrays? Well, we already learned from before. If this is 4x plus 8x, those are what we call like terms. So what can I do with these two? I can put them together. 4x plus 8x makes 12x because they're the same variable. All right, so now we're to key point number 2. This is the second and last key point, so my second and last joke. Ready? Did you hear about the lonely boy who started to date his calculator? Yeah, he said it really solved all his problems. All right, key point number 2. The distributive property still works with variables. So this is saying it doesn't matter if you're using variables or not, the distributive property will work the same way. So, example, given the expression x parentheses 3 plus 7, complete the array below. So we're going to set this up. X is on the outside. I'm going to distribute it to the 3 and distribute it to the 7. So x goes here, 3 goes here, 7 goes here. I know to find the area of this square, it's going to be 3 times x. Oh no, that's not what I wanted. Come on, 3x. And I know to find the area here, this is going to be 7x. So, my expression after I've used the distributive property would become 3x plus 7x, which equals 10x. And if you think about it, this makes sense, because x times 3 plus 7, well, 3 plus 7 becomes 10. So now this is just x times 10, which is 10x. All right, there are a couple of CFUs here. I'm going to do 2 of them, and then you're going to do the other 6, and we'll check them in class. Okay, so CFU, for each expression, complete the array, then rewrite the expression using the distributive property. So you're going to rewrite them after you distribute. So starting off, on the outside, I should have the letter T. Oh, come on. The letter T, because it's on the outside of the parentheses. Notice down here on like another problem, like here on E, the 3 is still outside the parentheses, so the 3 is going to go on the outside for this problem too. It doesn't matter if it's on the left side or the right side, whichever one's on the outside of the parentheses is what goes on the side. All right, going back up to letter A, T goes on the outside, 4 goes on top, 5 goes on bottom. I'm going to make these a little bit smaller because it's going to be hard to read what I need to do after this. 4, 5. So the area of this one would be 4t. The area of this one would be 5t. If I were to distribute here, t to the 4, t to the 5, this becomes 4t plus 5t. And if I think about it, it makes sense. Here's 4t from my first square, and here's 5t from my second square. Technically on this one, 4t and 5t are like terms, so I should combine these to make 9t. Not 99t. Alright, and then our next one, y is on the outside, so I'm going to put it on the side. 7 on top, 2 on top. This one would be 7y. This one would be 2y, because we're just multiplying times y. If I'm distributing the y to the 7 and the 2, this becomes 7y plus 2y, which equals 9y. And again, I can check. My first expression is 7y, and then my second one is 2y. So when I put them together, it makes 9. All right, that's it for this video. There are 6 more questions here that we are expecting you to come back to class prepared to check with, meaning this part here, none of this can be blank. You have to do these as part of the assignment because we're going to start checking them as soon as you come in. So do not leave these 6 problems blank. Give them a try so that we can look over them and analyze our mistakes if we make any and get ready to continue practicing. Okay? You guys have a good rest of your weekend, and we will see y'all on Monday.